2 looks at factorial notations. Factorial notation is using an exclamation point in math. So we can use the consider how many ways there are of arranging 6 different books side by side on a shelf. So if I have 6 books, how many different choices do I have for the first slot? 6. And then how many do I have for the next one? 5. And then? 4, 3, 2. So the number of different arrangements that I could make on the shelf would be 6 times 5 times 4 times 3 times 2 times 1. But remember, in mathematics, we are constantly trying to abbreviate everything with symbol notation. And that's where factorial notation comes in. Because I don't want to have to write 6 times 5 times 4 times 3 times 2 times 1. It would be nice to just say, let's do something with 6 that signifies I go from 6 down. That's my factorial. So if I say that I have 6 factorial, it's the same as saying 6 times 5 times 4 times 3 times 2 times 1. So if I have 4 factorial, it means 4 times 3 times 2 times 1. And what's 4 times 3 times 2 times 1 equal to? 24. So then 3 factorial times 2 factorial, what would 3 factorial look like if I expand it out? 3 times 2 times 1. And what does 2 factorial look like? 2 times 1. And because everything's being multiplied, I wouldn't even really need to have the brackets. I end up with 3 times 2 times 1 times 2 times 1, which equals 12. Now, when we start playing with factorials, we can start doing things like, you know what, 6 factorial, I don't want to just write it as 6 times 5 times 4 times 3 times 2 times 1. This 2 times 1 is the same as 2 factorial. So I could go 6 times 5 times 4 times 3 times 2 factorial. Or I could go 6 times 5 times 4 times 3 factorial, because that would be that 3, 2, 1. Or 6 times 5 factorial is 6 times all of this together. Well, why would I do that? Because then I can simplify factorials, such as 6 factorial divided by 4 factorial. I know 4 factorial is 4 times 3 times 2 times 1. I don't want to have to abbreviate it, expand it. 6 factorial I can now change as being 6 times 5 times 4 factorial. Anything divided by itself is always equal to 1. So it cancels out. 4 factorial on the top cancels the 4 factorial on the bottom. Leaves me with 6 times 5, which is 30. I could do the same thing if I expanded it out and did the same to the top and the bottom. Then I could cancel out my 4, my 3, my 2, and my 1. And that works for something like 6 factorial over 4 factorial. But if I had 97 factorial over 93 factorial, would you want to have to write out from 97 to 1? No. So then I could start off with 97 and go down till I get to 93 factorial, which then cancels out the 93 on the bottom. And then I'm left with 97, 96, 95, 94 that I multiply together. So now if we just do some practicing with this, it says express 5 as a product 4 different ways. So how can I express 5 factorial? What's one way that I can write 5 factorial?
5 times 4 times 3 times 2.
Yep. Okay, give me another way.
5 times the 4.
Yep. 5 times 4 factorial will 4.
That one. 5 times 4 times 3 times 2 factorial.
Okay.
5 times 4 times 3 factorial.
Good. Okay, so if I complete the following. 12 factorial is equal to what times 11 factorial? 12. Okay. 8 factorial equals what times 6 factorial?
8 times 7.
Good. Okay, so now let's go backwards. If I want to express this as a quotient of factorials, 6 times 5 times 4 could be what factorial over what factorial? So what did I start off with? Started off with 6, so that's what I'm going to put on the top. What don't I have in this? I don't have the 3, 2, 1. There's my 3 factorial. So if I have 15 times 14 times 13 times 12, what would that be as factorial, as a factorial quotient?
15 factorial over 11.
Good. Okay, so let's look at the next two. Without using a calculator, let's simplify the following. So if I have 10 factorial over 7 factorial, what could I do? What I want to do is I probably want to eliminate something on the bottom. So I want to eliminate this 7 factorial. So how do I use 10 factorial to get to 7 factorial?
Can you go 10 times 9 times 8 times 7 factorial and then cross them out?
And then cross them out. Good. And then figure out the product of 10 times 9 times 8. Other way around. Not 270. 720.
Wow.
They have the right numbers.
I started
Yeah.
thinking a 7 and then I started changing it to a 2. Like, wow.
Okay, what about 8 factorial divided by 5 factorial, 3 factorial? What could I do? What did you write out, Rachel?
Well, so far I have 8 times 7 times 6 times 5 factorial.
Okay. So then that is going to cancel out that 5 factorial on the bottom.
And then you have the 3 factorial still, but then could you just go like 8 times 7 times 6 divided by 3 times 2 times 1?
Okay, so 3 times 2 times 1. So I canceled out the 5 factorials. Is there anything else I can cancel out? What's 3 times 2?
Oh,
So 3 times 2 will cancel out the 6. And that leaves me with 8 times 7, which is 56.
65.
65.
Okay, so factorial notation by definition says if I have n factorial, it's the same as going n times n minus 1 times n minus 2 times n minus 3 until I get to 3 times 2 times 1. N has to be a whole number. You cannot do factorial of 3.5. Okay? You can do the factorial of 3, you can do the factorial of 4. You cannot do decimals, you cannot do negatives either. Okay? So n has to be a whole number. 0 factorial is actually equal to 1, and we'll investigate that a little bit later in the lesson. And then remembering that n factorial can be written different ways. It doesn't have to just be n times n minus 1 times n minus 2 times n minus 3. I can go n times n minus 1 factorial. So I can stop at any point in time and then just, if I stopped right here, it would be n minus 3 factorial. And that helps us to do some simplification of the next problems. So if I have n factorial is n times n minus 1 times n minus 2, or in this case, n times n minus 1 factorial. Now if I have n plus 2, that means it's n plus 2 times what? What's 1 less than n plus 2? N plus 1. And 1 less than n plus 1 is n, and then I'm at n factorial. So if I look at this one plays tricks on us, because when we look at it, the 5, the 4, and the 6 are going up, but then I've got 3, 2, 1 that are going down. This is not 5, 4, and 6. This is n minus 4. So it's a number subtracted by 4. Something like 10 minus 4 would be 6. 10 minus 5 would be 5. 10 minus 6 would be 4. So these 3 values are decreasing because this is a unit. It's n minus 4. So n minus 4 times n minus 5 times n minus 6 down to 3 times 2 times 1. How can I write that as a factorial? So what's the largest number in this string? N minus 4. So I get n minus 4 factorial. And we do put the n minus 4 in brackets simply because we want the factorial to go to the whole factor. Question number 2 says simplify the following expressions. Leave the answer in product form where appropriate. So you're always trying to cancel things out. So the best way to do that is to look at the top or the bottom and figure out which one is bigger. Is the top value bigger than the bottom value, which is a little bit trickier when you're dealing with algebra, but if you have to, just pick a number for n. If n is 10, I've got 12 on the top, 10 on the bottom. The 12 is bigger. Start with the bigger one and start decreasing, or start expanding it. So n plus 2 times what? Times? Pardon?
And n factorial.
Why would I stop? Why would I put n factorial at that point?
Well, because 1 less than n plus 1 would be n plus 0.
And then what am I trying to do?
Cross that.
Trying to cancel out, so then I can stop. So if we leave this in product form, I get n plus 2 times n plus 1. So I'm going to give you a couple of minutes to see if you can do how you can do on B and C. So n minus 2 factorial over n minus 1 factorial. Which one's bigger, the n minus 2 or the n minus 1?
N minus 1.
N minus 1. So that's the one that I want to expand out. So then the n minus 2 on the top cancels the 1 on the bottom. I'm left with 1 on the top over n minus 1. Okay? And then for C. What'd you get?
Get the n times n minus 1 over the top.
N times what else? What's after n minus 1?
N minus 2.
But I don't really need anything after these two because I'm trying to cancel them off with the bottom. So I can leave this as n minus 2 factorial. So then these all cancel, and what I'm left up to is n minus 2 factorial. I went to expand this out simply because I don't know what n is, so I wouldn't really know where to stop and then where to end up to with my 3, 2, 1. So I would leave it as n minus 2 factorial. So now that we've simplified these, we can actually solve equations using factorial notation. So if I look at this one, this n over n minus 2, which one's the larger value, the top or the bottom? The top, so that's what I'm going to expand. So n factorial, if I expand it out, becomes what?
N times by n minus 1, n minus 2 factorial.
And then that cancels out the n minus 2 factorial on the bottom. So that leaves me with n times n minus 1 equals 42. And then how would I proceed from this point?
Would you like expand the n into brackets? You'd have n squared minus n.
Okay, so n squared minus n. Then what?
I'm not going to answer. Okay. Minus 42.
Minus 42, so bring the 42 over. Okay, so that equals 0. And then what would I do?
Factor it. So it'll be like
So negative 7 and positive 6. So I get n minus 7 and n plus 6. So what can n equal?
7 or negative 6.
Okay. Do these two answers make sense? So does 7 make sense? Can I have 7 factorial and 7 minus 2 factorial? Yeah. Does negative 6 factorial make sense? No. That's eliminated as an answer. My answer would be 7. Okay. And just the last part, before you start working on some practice questions, using the factorial key on your calculator. So on the 84s, the factorial key is found by pressing math, and then you have to go to PRB, which if you go left, is faster than going 3 to the right, and it's choice number 4. So before you pick it, you have to type in, so if I wanted to do 6 factorial, 6, and then math to PRB, choose 4, and now it comes up 6 factorial. Press enter, and there's my 720. So if I do the same thing with 9 factorial, what do you get?
$362,900.
Good. Okay. And you can actually simplify something like 10 factorial divided by 7 factorial, 3 factorial on the calculator. You can do the top and the bottom separately, or you can do them together. Just put the bottom in a set of brackets. So if I did this as a one step, I would go 10 factorial divided by, and then I would open my brackets up so that I could put in 7 factorial, 3 factorial. And I get 120, which is the same thing as taking 628,800 divided by 30,240. It's the same thing. If I verified it without using a calculator, I get 10 factorial, 10 times 9 times 8 times 7 factorial, and then the 7 times the 3, 7 factorial times 6, because that's what 3 times 2 is. So the 7's cancel out. With this, I can go 6. See, I would have left this probably as a 3 and a 2. Because then the 9 divided by 3 would give me 3. 8 divided by 2 would give me 4. And I have 10 times 3 times 4, which is still 120. Okay, so using your calculators, tell me what the value of 40 factorial divided by, 43 factorial divided by 40 factorial, and for B as well. So I'll give you a minute to work on that. Okay, so what do you get when you go 43 divided by 40 factorials?
74,046.
Yep. And then the 37 factorial divided by 33 factorial, 4 factorial?
66,045.
Okay, so your practice questions, questions 1, 2, and 3. And then for question 5, B and C, and 6, B and C. Okay, we're going to look at the next section. We're not going to worry about the wording or the terminology of permutation. We're going to look at the example. So I have an access code to the internet site. It's a 3-digit number. Knowing the 3 digits isn't enough. The order that they go in is important. So even if I told you that the digits were 3, 5, and 7, how many ways could I, or how many different access codes could I create? So one access code would be the 357. What could another access code be using those 3 numbers?
753.
Okay.
573.
Okay.
735.
375. And 537.
So there's 6 possible arrangements to consider. Only one of them is going to access the site. So when I have order importance, we call it a permutation. Like I said before, a lot of these questions can be calculated with factorials or the fundamental counting principle. The idea of permutations and combinations, we don't necessarily need to stress ourselves out on is this a perm or is this a comp. We can look at the fundamental counting principle, we can look at the basics of the question. So by definition, a permutation is an arrangement in which order is important. So that's the internet site. Winning the prizes in the contest, the one that you guys were looking at yesterday with the first, second, and third. That's a permutation because the order is important. It matters whether or not you've got the second prize or you got the first prize. It's a big difference. So if I have the word cat, or sorry, the letters of the word cat, how many ways can I arrange those 3 letters?
Could have TAC, ACT, or ATC. CTA
And TCA.
So when you're listing them out, trying to have some sort of a organizational tool helps. Okay. If I have to write this as a factorial, how can I write this as a factorial? So I have 6 numbers, or 6 different arrangements. So this time, instead of starting at the top and going to the bottom, let's start at the bottom. 1 times 2 is 2, times 3 is, which is what I have. So what is this as a factorial? 3 factorial. So what this means is if I have 7 letters and I'm arranging those 7 letters, the number of arrangements that I have will be the same as 7 factorial. I had 3 letters. I'm rearranging the 3 letters. Fundamental counting principle. I have 3 choices for the first spot, 2 choices for the second spot, and 1 left for the last. That's the same as 3 factorial. So if I take the letters in the word Regina, how many different arrangements can I make with those letters? So how many letters do I have? So how many choices do I have in the first spot? Times 3, 2, 1. So that's the same as 6 factorial. What is the value of 6 factorial? Yep. Okay, what about Kelowna?
7 letters would be 7 factorial.
And what is 7 factorial?
Sorry.
And I could do that one of 2 ways. I could have gone the 7 factorial, or using 720, multiplied it by 7, because it would just be the one more. Okay? What if I don't take all of the numbers at a time? So suppose I have the word graphite. Graphite contains 8 letters. I only want to take 3 at a time. 3 letter arrangements. So how many choices do I have for the first spot? 8. How many for the second?
7.
And 6. So let's say I wanted to be still able to use this 8 factorial. Well, I can't just use 8 factorial because I don't have the 5, 4, 3, 2, 1. So then what could I do to get rid of the 5, 4, 3, 2, 1?
Divided by 5 factorial.
What's the difference between 8 and 5? How many arrangements do I have? 3. So the 8, the 5, and the 3 end up getting this relationship. What I end up having is I have this number of permutations of 8 elements that I'm taking 3 at a time. The way that we write it is we write it as NPR. So the N is 8, that's the total number of elements I have in this set. R is the number that I'm picking at a time. I'm choosing 3 at a time. What it equals is n factorial divided by n minus r. In this case, 8 minus 3 gives me my 5. This is on your formula sheet for you. You're not expected to memorize it, but you do need to know the permutation one and the combination one, which one you use for which situation. Remember, permutations order is important. So it says use the NPR key on a calculator to evaluate it and then verify it using factorials. So if we use this on our calculator, we have to put the 8 in first. We access that NPR the same place that we found the factorial. So math, and then to PRB, which is probability, and it's choice number 2. So then, depending on your calculator, mine says 8 NPR, and then I have 3. Press enter, and I get 336 arrangements. So if we were to verify this with factorials, so the calculator tells me this is 336. Factorials tells me it's 8 factorial over 8 minus 3 factorial. which is that 8 factorial over 5 that I had put up here. I can expand out 8 factorial to give me 8 times 7 times 6 times 5 factorial. Cancel these two out. And 8 times 7 times 6, which is 336. So it still works out. So that helps us define 0 factorial. If we replace r by n, what we get is we get the number of permutations of n elements taken n at a time, which is known as n factorial. So if I were to replace this, we know from right here, the number of permutations in the word Regina is 6 factorial, because I'm taking them all together. So we know that npn is the same as n factorial. If I use the formula, it is n factorial over n minus r, which in this case r is equal to n. So I get n minus n, which is 0. Well, in order for n factorial to be equal to n factorial over 0 factorial, 0 has to have a value of 1. So 0 factorial has to equal 1. And that really is the best explanation for it at this point. So I have 2 more examples. In a region, vehicle license plate consists of 2 letters followed by 4 different digits. If the letters I, O, Y, and Z are not used, how many different license plates are possible by using the fundamental counting principle and by using permutations? So I have 2 letters followed by 4 digits. Two different letters, meaning no repetitions. And I cannot use the letters I, O, Y, and Z. So how many choices do I have for my first letter? 22. How many for the second?
1.
Okay. And then I have my digits. 4 different digits. So how many digits do I have possible for the first choice? 10. And then?
7.
Okay, so if I multiply all of that together, what do I get?
2,328,480.
480?
Yeah.
Okay. Now if we look at this from a permutation standpoint, I have 22 letters. How many letters am I picking? I'm picking 2 in all. So 22 letters, and I'm picking 2 of them. Then I have 10 digits, and how many am I picking? So do this calculation and see if you get the same value. Did you find the...
I found the button, but I don't know how to use it.
Okay, so do I get the same amount?
Oh, I thought it was like some.
Do I get 2,300,000 and some thousand?
Yeah.
Okay. Okay, last question. An algebraic equation involving permutations. So I'm picking 2 out of I don't know how many, and I want that to be equal to 90. There are 2 ways that you can solve this. Okay, actually there's 3 ways. You could guess and check. You could start typing things like, what is 10p2? What is 6p2? And so on. So you could do a systematic approach that way. You could graph this. Graphing's going to be a little bit tricky because of the way that the graph looks. But what you could do is you could set it up as a graph and then look at the table of values. So if I did that, I went into my y equals, I clear my two equations, and I'm going to go bracket x minus 1 bracket, and then my NPR button, so math, and then I have 2, and then I have y2 equaling 90. If I go to my table, which I might want to check my table start at 1, going up by 1s. If I start scrolling down through the list, I want to look at when the two values equal, and that's when n equals 11. So that's the other way that I could do this. However, how do you think we're supposed to solve this? Probably not that way. No, probably not that way. We want to use algebraic means to solve this. So to solve this algebraically, we're going to use the definition of the permutations. So NPR means n factorial, so that's this part here, divided by n minus r. So n is n minus 1 minus r factorial. So what is n minus 1 minus 2? N minus 3. Which I know is going to be smaller than n minus 1. So I'm going to expand out n minus 1. And n minus 1, n minus 2, n minus 3, which I'm now going to end with a factorial. So I can cancel those out. So then I have n minus 1 times n minus 2 equals 90. And how would I proceed at this point? What would I do next?
Like, expand your n minus 1 and n minus 2.
Okay, so n's
Move the 90 over and then factor.
Okay, two numbers that multiply to negative 88 and add to negative 3. So negative 11 and 8, which means that n would equal 11 or negative 8, but negative 8 doesn't make sense. So we can eliminate it, and I have that n equals 11. So depending what the question looked like can kind of lead to how you would solve it. This question saying algebraically solve it means that I would be looking for an algebraic solution. But if this was a multiple choice question and you had the 4 answers, you could stick the 4 answers in and guess and check. If this was a numerical response question, you could still use the table feature on your calculator to come up with 11. Okay? So in a lot of these questions, the fundamental counting principle is going to probably work just as easy as the permutations are. So questions 7, B, and C